Hi, and welcome to TEMEKO. In this video, we will continue with the previous topic in which we discussed about the moment of a force and how to define the moment by using scalar and vector formulation. This time, however, we will discuss about a slightly different case in which the moment is created by two parallel forces, which is called the moment of a couple. We will look at how this kind of moment differs from the moment that is created by one force. We will also learn how to determine this moment by using scalar and vector formulation. Let's get started. So, what is the moment of a couple? We can define the moment of a couple to be the moment which is created by two parallel forces which have the same magnitude but have opposite direction. These forces are also separated from each other by a certain perpendicular distance d. We can determine this moment of a couple about any arbitrary point O as follows. MO equals RA cross minus F plus RB cross F, where RA and RB are the position vectors which are directed from the point O to points A and B lying on the line of action of the force couple, which consists of F and minus F. On the other hand, as some of you may have already concluded, we could write this equation differently as shown here. MO equals RB minus RA cross F. By using the triangle rule of vector addition, we can determine the position vector r to be r equals rb minus ra. If we use this definition for the position vector and we substitute it to our defined couple moment equation, the equation will be as follows. MO equals r cross F, which is actually equal to the moment of a force equation that we are already familiar with. M equals r cross F. But what does this tell us? It tells us that the moment of a couple depends only on the position vector r directed between the forces and is not dependent on the separate position vectors ra and rb directed from the arbitrary point O to the forces. This kind of vector is called a free vector. We can transfer a free vector to any arbitrary point on the body, and the result would always be the same. This is what differentiates the moment of a couple from the moment of a force, which depends on a specific point or axis about which the moments are determined. How can we possibly calculate the magnitude of the moment of a couple then? Well, like in the case of the moment of a force, we could use a scalar formulation. Based on the previous derivation, the magnitude of the moment of a couple can be determined by using the following equation. M equals F times d, where F is the magnitude of one of the forces and d is the perpendicular distance between the forces. The direction of the moment of a couple can be determined by using our familiar right-hand rule, where the right-hand thumb indicates the direction when the right-hand fingers are curled to the direction of the forces. The moment of a couple will be perpendicular to the plane, which is formed by the forces. Like in the case of the moment of a force, we can also use vector formulation for the moment of a couple when we are dealing with complex problems. In vector formulation, the moment of a couple can be described using cross product as follows. M equals r cross F, where r is the position vector directed between forces and the force vector F is one of the forces of the force couple. To determine the magnitude of the moment, we would typically use Cartesian vector formulation and then solve the equation by using the familiar determinant solving method. Hopefully, after watching this video, you know the definition of the moment of a couple and how it differs from the moment of a force. You also know how to determine the moment of a couple by using scalar and vector formulation. Thanks for watching and have a nice day.